at the defense, there's a big gap between the two of us. And when we go into companies, or you go into a company, and who here is a pen tester? Who here is on the blue team? When we go in, we use different techniques. You folks do different techniques to defend against. And it's always a cat and mouse game. It's, making sure that you have things in place that hopefully you can detect who's coming in and breaking into your company, whether it's a good guy or bad guy or whatever not. So this talk is really about that. Just a quick introduction. I'm Dave. I'm not going to go through my introduction slides. Jamie.
I'm Jamie Murdock. Known Dave for a couple years. I'm the CISO at BDS, Binary Defense Systems. I see some shirts. Most of them are ours anyway. And there's a little bit about me. It's not really important.
It's funny, Jamin and I, I used to do work with a bank that he used to work with, and I hired him over at Diebold when I became the CISO at Diebold, and then brought him into BDS. And it's funny because, I used to always prank Jamie all the time at Diebold, and now I'm getting like all the retaliation back now at the new company, so I'm always on my toes. Where's Martin at, by the way? Is Martin here? Martin in there? No. So that's a picture of Martin being a thought leader, an evangelist. Anyways, so we look at the different types of breaches that are happening out there, and we continue to see a lot of large breaches. I mean, there's money to be made, whether it's stealing credit cards or going after IP or whatever it ends up being. There's a lot of different techniques out there that attackers are going after. And for me, when I look at it, the industry is kind of going in a bunch of different ways. It's kind of going left and right. And one way is kind of going through and looking at the different types of technologies that you can implement to fix security problems. And you also have the other side, which is building security kind of from the ground up and changing the culture. And then from there, once you have a program, establishing it. And so if you look at that, we see a lot of the technology today failing. I'm going to demonstrate a lot of the different types of attacks that you can use to get around a lot of the things that we use for defense, like next-gen firewalls and application whitelisting and everything else out there. We'll get around all of that. But really, we look at it, and it's not really a challenge for us as attackers to get around this stuff. Just maybe a little bit more effort, or we've changed our ways a little bit to modify things a little bit to get around certain different types of detection mechanisms. So we're definitely going to be talking about that in this talk. So if you look at the past, present, and future, I mean, you look at the attacking industry. Like as a pen tester, we have a very, very easy job. It only takes one flaw that you've done, or that a developer did, or something that you missed, or something that someone else missed, in order for your entire security program to crumble and fall. Now, let me ask you a question here. Folks that are on the blue team, do you know everything that's going on from a technology perspective in your company? No, there's no possible way, right? Do you know every project or every iOS device or every executive that's doing something that he probably shouldn't have? No, right? Do you know when a new application gets installed and it's done in marketing in the cloud? No, right? So we have all of these things. It's not a bad thing. It's just technology moves so fast within our organizations. We try to kind of get our hands around it, but it's moving so fast and forward, it's really difficult for us to look at it. And only one of those things can cause the entire company to become a downfall. And that's a really bad statistic, because we have to be right 100% of the time on the blue team. And that's a tough challenge. And so if you look at it, I mean, the reason is the ability to detect a skilled attacker in an environment is difficult, especially if we emulate regular traffic, right? Whether it's HTTP or HTTPS or RFC compliance, something or another. If we're using things that would be legitimate purposes, it's very difficult for us to detect that unless we start doing crazy things like sweeping the network or port scanning or, brute forcing accounts or whatever, and then we might have a chance. But if we're looking at it, someone that's skilled that can actually go in and target an organization and be very stealthily, going about it and use everything that would be normal, legitimate traffic, how do we detect that? And that's a problem we have today, because if you look at where attackers are moving to, they're moving to that model. It's moving towards using, what we use on a regular basis that's consistent in every company. I mean, everybody uses HTTP and HTTPS, right? Right? No? Anybody not here use HTTP or HTTPS? Just curious. If someone raised their hand, I would actually call you up and ask how it's possible. Gopher. So, and that's a problem, because, as you look back 5 or 10 years, attackers are being kind of blunt. They're running scanners or whatnot. They're dropping executables on a machine that, you have a possibility of getting a binary picked up or something. They're using these techniques that we all kind of built everything around 10, 15 years ago. You fast forward, now attackers are using persistence in PowerShell. there was someone that was doing a presentation at a local Cleveland chapter, and they're using non-printable ASCII characters to hide the malware in registry, and it's a purely registry living piece of malware. I'm like, that's brilliant. Are we ever going to detect that? I don't know. I don't know yet, but the types of technology used today, it's really hard to determine the two differences between malicious and non-malicious traffic because we have no idea what's going on in our networks. And that's what we're here to talk about today. And one of my big pet peeves right now in the security industry is our over-reliance on technology. I understand that we're trying to protect technology and information. But when you implement technology, let me ask you a question. Does anybody here have a next-generation firewall? And I'm not going to pick on you, by the way. You can raise your hand. I'm not going to make fun of you or anything. Is that a problem? It's a good thing, right? So next-gen firewalls, the way that they work is by looking at behavior or whatever, which is basically signatures from like the 90s, but over the wire, right? And they look for patterns of attackers, right? So it might catch an interpreter session or, the slammer worm virus, which I actually saw next-gen firewall have definitions from the slammer worm. I'm like, that's great. Really? Anyways, so you have these pieces of technology. And let me ask a question. When you took that next-gen firewall and you put it in place, did you actually carve out your infrastructure and architecture and put segmented zones based on roles within your organization, like network segmentation in place? No? Did you actually identify where your assets are and try to put high security zones in place to protect your core infrastructure and kind of map it out a little bit so that users are in one and those users are segmented based on departments so they can't access other people's information and your data centers are all segmented appropriately? Did you guys do that? Or did you just click the little importer tool from the Cisco that you had, which you've run for 14 years and it's been gross negligence for 14 years, and you just hit import into your next-gen firewall, you tested it, and everything's working perfectly now. So what does that next-gen firewall do for you? Nothing, right? You might get a little more detection capabilities on it, right? But that's about it. So we have this thing where it's like, hey, we're going to pop this thing out and move something else in, and all of a sudden now that's going to fix all the world's problems. And what I love is that the big, buzzword was DLP, starting 4 years ago or something like that, right? So it was everybody's DLP, 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 right? And so everybody's oh, now compliance requires it, so we need DLP here, we need DLP there, we need to catch this. Let me ask you a question. Does anybody here have an information classification program where all of the data is tagged and categorized, and you can actually look at that data elements and see as it's going out which ones you want to protect against, and you're looking through your whole network trying to find exactly where your sensitive information's at? Everybody laughs, right? Because no one's done that shit. Sorry for the language. No one's done that before. Or if they do, it's at a very small subset of their organization. And so everybody has DLP now, and it's basically a big regex for social security numbers and credit cards. That's it. That's all it does. Listen, guys, you can write that stuff in Python in 10 minutes. Python's better than Ruby, by the way. So, excuse me. Sorry. I don't think Egypt's in here, so I can say that. Yeah, he's not in here. Good. Awesome. I might have got tackled. So, that's the problem we face, is that, we have the solution. Now, let's talk about the DLP situation, right? So you did this DLP implementation. You spent millions of dollars on this piece of technology, right? And you're sitting there and you're using social security numbers and whatever, and you might have got a person to actually staff it. Most likely you probably didn't. And the person that was already overloaded took over the DLP stuff, which he's half doing that and half your vulnerability management and half of patching servers and all of your firewall rules and everything else, which, he can all do all that really cool. It's fine. It's no big deal. And then on top of that now, we have next-gen firewalls. So you spend all this money investment on DLP, and now you're oh, I need to get this next-gen firewall. I need to get this. We're going to implement this now. And what happens to that DLP solution that you kind of half implemented anyway? Shelf, right? You're bloop, focus on that now. And now that person's now on a next-gen firewall. Now he's on DLP. Now he's on this. Now he's on this. And you keep spreading it out to where we come to a point where we're not even manageable anymore in InfoSec. We're not doing anything anymore. We're just waiting for that email alert to pop up in our next-gen firewall to say, hey, there's a threat. Or for FireEye to tell us that someone's trying to APT us, right? That's all we do now. We're waiting for that message. We're not analyzing. We're not looking at things. We're not understanding our infrastructure. We're not driving a security culture that can fix things, and that's a problem.
Something else that a lot of companies aren't doing, which is something they really should be doing, is incorporating threat intelligence into what they do. If you look at the defense in depth model, you have your nice pretty onion, but anyone in here at all incorporate threat intelligence into their little defense in depth model? Good. That's more than I usually see. So a big part of that also is, I've talked to people and they say, well, you know what? I'm a small company. I don't really need to worry about a lot of this stuff, especially, this whole threat intel thing. I watch CNN, I see Dave, and he tells me everything that's going on. Well, maybe that's true. Maybe you don't have anything in your company, any IP that, anyone might not go after. The thing is, what about those who you service? What about other companies that you have connections with? Attackers are getting smarter. They're getting a lot better about what they do. So they target executives of smaller, medium-sized companies. They target their employees. That way, you're easier to get if you're one of those targets than somebody that you service.
And I just want to give an example to put it in perspective. We were breaking into a bank, which is like the coolest thing ever, because it was like night ops missions, and Nick's like there with like night vision goggles and a cemetery running across the street and all this other stuff. It was pretty fun. Anyways, but when we're doing the web application piece, we gone through some conference calls and kind of went through the whole P-test model of pre-engagement interaction, understanding what they want to accomplish out of the pen test. And one thing that they were very confident in was their technology. They're like, we have this tool and this tool and this tool and this thing and this sensor and this company that monitors our stuff and this and this and this and this, right? And the first day we ripped into them, like everything, not one alert or not one thing, not one of their preventative measure technology stopped us. And this is through a WAF and everything else, and it was just like they had every piece of technology you could possibly imagine, and we ripped them and took everything that they possibly could hold dear to themselves without one alert. Now, take a different scenario. We're doing a company from a really small security team, a big company, really small security team. But what they focused on was a little bit different. They focused on changing the culture inside, focusing on building programs, not necessarily the technology. And what was good about that is we actually were going in and we found a flaw in their system. As soon as we compromised it, we got an alert. They got an alert saying, hey, something's not right. And it was something weird, like we're dumping the SAM database through volume shadow copy. And they had created their own alerts on that based on a talk that they saw when they went to a security conference. And that's what they built the signatures in, and it didn't cost them any money, it didn't cost them anything. It was just an event log that is created. They centralized that at least, and they were able to detect that. That was amazing and impressive. Now, don't get me wrong, they still have problems, but they at least have things that they look at and they continue to build in that's not just technology-centric. They're focusing on understanding how we think and attack. So you look at the methods of attack, all right? It's the same stuff every single time, right? Do you know, so I started, I worked for the Marine Corps and the NSA and all that stuff from 2000 to 2005, before that, a program MUDs and everything. When I started hacking, which was, I guess 13 years ago or so, okay? 14 years ago, Jesus, I'm getting old. 14 years ago, the same types of techniques I use today, or then, are the same types of techniques I use today. Like SQL injection. How old's SQL injection? A hold, right? How old's buffer overflows? Like well before I was even born, right? I know some of you guys in here were there when it started, but anyways. That's the same type of stuff that we're using today. Our methods may have changed slightly, but the same way that we're getting owned every single time is through that. I mean, you look at, and I hate using references of companies because we all falter as organizations, and this isn't to point out the flaw in a company, but the Target instance was a third party. How long have we been talking about the problems with third parties? Does anybody remember? I mean, I can't remember when I wasn't talking about third parties being a threat within organizations, right? So we have all these things that we continue to get owned by simple stuff. SQL injection, I mean, MS-0267 and still environments where they forgot about a server. I mean, simple vulnerability scanners pick that stuff up. I mean, we continue to see it over and over again. And so what you see is, you get all this technology, and then it becomes less focused on security, more focused on managing the tools because the tools are so hard to manage. And on top of that, we have compliance, right? Has anybody here been through a compliance audit before? Yeah? Is that awesome? Like PCI, right? You got to go through the whole PCI standard. Phenomenal. It's rocks, right? And if you don't have the documentation, you got to create it really quick, and the data flows, and you got to do segmentation and all that stuff. Let me ask a question. Does anybody here have enough people dedicated to security? Does anybody here have enough funding for the security program? So let me get this straight. You don't have enough funding. You don't have enough people. You have to go through audits, and you buy new technology. Does that make sense? No, it doesn't. So I'll prove it in this point here. Who here feels like they haven't been breached before ever in the history, and they know that for a fact that they haven't been breached before? Anybody feel confident? That's a problem. That's a problem we don't understand what we're doing. It's not that we don't understand what we're doing. It's a problem we don't know what's going on in our infrastructure. It's a problem that we don't have a culture that focuses on security. And so let's talk about shifting the dynamics in our defenses against attackers. So today, I'm gonna kind of walk through my traditional pen test, okay? This is how I break into companies, okay? We own some stuff, we own some more, we blow some other stuff up, then we report on what all the stuff we blew up on, right? Does that sound about right? Pen testers? Blow some stuff up, blow some more stuff up, and then we're all like high-five. We're like, yeah, man, we just got this, and we go in, we write this report, I'm like, oh man, we got a report, crap. And we go from adrenaline pumping and owning systems and stealing money and all this other stuff to, here comes the report. I'm just going to delay this and code something or go watch TV or something. I'll get to the report tomorrow. And then after that, the blue team, you may fix some of our findings. You go through our technical findings and you're like, hey, we got SQL injection. All right, we're going to use prepared statements and stored procedures or parameterized SQL queries to fix that. And all of a sudden, we're all set now, right? Then after that, we blow you up again. We blow up again just from a different perspective. And so we look at that and we say, well, geez, is pen testing not working? I mean, I'll be honest with you. I have as an offensive person, I have one of the easiest jobs in the world. Because all I have to do is find that one flaw. And usually I find that one flaw the first day, and then after that I just write tools and code the rest of the day because I can release a new tool. And I have your entire environment to test it on, so it's perfect for me as a dev. I mean, technically we're not even doing pen tests right now anyway. We define pen tests. I saw an article released about what the government classifies a pen test as, and it's a vulnerability scanner. And it was something to the effect of, we simulate what a hacker does by being ethical hackers and running vulnerability scans against our environment to simulate that hacker to find our exposures. And we laugh, but that is the perspective of a lot of people. And that's the perspective of a lot of the commoditized pen testing companies you see out there. They just run scanners. They might exploit a couple of them and say, hey, cool, dude, we got this and that, and that's it. That's your pen test. That is not an attacker. We need to evolve. We need to get better. We need to focus on getting more than just domain admin. In order for us to defend our blue team, you need to understand what we're doing. Let me ask a question. Do you know as a blue team member, anybody here in the blue team? Raise your hand. Keep your hands up just for a second. Does anybody here know all my techniques that I use as an attacker? Red team, put your hands up. Do you know all of the ways that the blue team defends? Not many. We don't understand each other. And we're in the same industry. We're the same exact industry. We're in InfoSec, and we don't understand each other. Let me ask you a question. How many specializations are there in just the pen testing field? Dozens, if not more. We have reversers. We have iOS developers and mobile bug hunters. We have people that focus on just network exploitation, exploit dev. We have people that focus on web applications, SQL, Oracle, whatever it ends up being. We don't even understand each other in our own field, let alone what the blue team's doing or what the red team's doing.
So we talked just a little bit about threat intelligence. There are some people in here that are doing it, and that's good. But, a lot of people say, well, why is that important? Who really cares? It's a new buzzword. I'm not really going to worry about it because just like DLP, it's just going to go away some other time, and some other buzzword's going to, come and take it away. Well, the threat landscape has evolved so much now that there's a lot of really sophisticated groups, some of which are state-sponsored, that are going more and more and more for the attacks. And with social media, they see somebody, or they hear about some kind of attack or some kind of operation, and then you have all these other people going and saying, you know what, I want to do that too. So you're seeing more and more attacks, seeing more and more targeted operations. So I was wondering who that was for. You're lucky because you don't have your bands. I almost did it to you.
Don't worry. I carry them in my pocket just in case.
Nice.
That's me. You thought you were going to get me, huh?
So, something else we're seeing a lot of is, you have geopolitical issues, you have social issues that are being mirrored, and I know the word's in there, but mirrored in the cyber world. What happened when Russia invaded Crimea? The U.S. put sanctions on them, right? If you go back and look at the number of attacks and attempted attacks that started from Russia and Russian supporters to, before these sanctions went in, you can see it just go like this. Every time the President of the United States, before the newest issue with Syria, would say something about Syria, you would see the escalation again. So things that are happening in the real world are coming at us now, and we have to defend against that. Well, how are you going to defend against it if you're not paying attention? You don't know what's going on out there. So by actually proactively using threat intelligence, whatever monitoring capabilities you have in your organization, you're going to improve that. You're going to give yourself more to watch, which, yeah, I know, blue teamers, it's, you never really want to hear, oh, you got more to watch now. You got more to watch now. But this is good stuff that you're creating. And it's also going to help decrease your response time. If you know what's going on out there and you're looking, and you're staying current, you're staying fresh, and you're writing content specifically for that, well, if you're a target, or you just happen to be, somebody they want to test on, well, you're going to respond faster to that.
One thing I want to hit on, too, is back to that blue team, red team thing, is, we need to understand, on understanding each other a lot better. It's funny, we'll be on a pen test, and I'll be like, I just did a new technique. I'm like, hey, I just did this, it was awesome, I blew this up, and I blew this. I'm like, oh, man, I got to figure out how to detect myself now. So and then I send my email, and I'll do like a video and like some code and everything. I send it over to Jamie. I'm like, hey, Jamie, figure out how to detect this. Sorry, dude. And then, I go back to hacking again, and then I send him another one 2 hours later. I'm like, hey, also, can you figure out how to do this one too? And then and it's funny, I do that all over. I do it on the red team side too. I'll write a new tool, and I'll forget to tell my guys about it. And I was just in Black Hat training a class, and I was like going over a tool that I wrote, and Larry was in my class, and he's like, seriously, dude, when did you write this? I'm like, I don't know, like a year ago. And he's like, are you kidding me? He's like, that's the awesomest thing ever. You didn't tell any of us. I'm like, I put it on GitHub. I mean, but it goes back to that, understanding and sharing what we're doing between each other, because it's so effective to understand how we think and how you defend. We'll do a test, and I'll be sitting with the blue team member and be like, hey, this is what I'm doing right now. I just want to let you know that this is how I'm breaking in. And he's like, oh man, I know how I can detect it. You can do this, this, and this, and this. I'm like, seriously, you can do that? That's awesome. Now I can do this, this, and this, and now I'm going to use that to get around you from now on. Thank you so much. So it works both ways, but it's always beneficial for us to understand each other. And getting that information and understanding how the attackers out there, from different countries are breaking in is also important.
And by taking that information, not just from a threat intel perspective, but taking that information that you get from, your pen testing, whether it's internal or external, whether it's you doing it or somebody else doing it, like Dave was saying before, work that in with what you get for your monitoring. What sense does it make for a company to have a pen test done, and they get their report, which Dave loves to write, and then they go, oh, wow, okay, well, this is what we need to fix, this is how we need to do it, great, and it goes on a shelf. Or maybe it goes to, the server teams to do patch management, or they do something like that. Okay, that's great. But what about that report don't you want your blue team to focus on? This is basically a guidebook for them to say, here's where we have flaws right now. Here's how they got in. We didn't catch it. Why didn't we catch it? Okay, well, let's go through this report and let's start fixing things.
And that's what we have to look for on those pen tests, isn't the technical findings. You can actually take the part of the report on the technical findings and almost blow it up and just burn it up. Now, granted, you might have to fix a couple issues that you have, but what you have to look for when you're talking about something on a red team are systemic issues in your program. If I break in through a flaw, why was that flaw there in the first place, and what can I do, A, to detect it in the future, and B, to prevent it in the future? Let's just say I have SQL injection on this website here. Well, this website was contracted by a third party, they developed it, and it's there. Well, now we have a problem with how we actually vet our third parties and how they do secure coding practices. Can we work with that company on getting secure coding practices and have it tested appropriately on our side? That's program related, because what happens when I break in with SQL injection 1 year and you fix the SQL injection that same year and I come in next year? What happens? New SQL injection, right? You didn't fix the root problem. You didn't go to the crux of why that's there in the first place, and that's what we need to focus on. And so look at the red team, right? I'll talk about the red team and the blue team. This is my favorite part of the slides. And that's Congresswoman Edwards yelling at me in front of Congress. And I put her in every one of my slides from now on, just to remind me. You can tell she's really angry. Whatever. Anyways. So as a red team member, we're assigned to a company, right? And you may have a significant amount of assets. You might be a small, medium-sized business. You might be a large-sized business. Usually what we do is what we call covert testing, right? Where we don't tell the security team in that company, the defense of the blue team, that we're coming in, right? It's a secret, right? And it's funny because usually like 99% of the time you guys know what's happening anyway. You're like, no, none of our guys know. We're cool. Hey, we saw this single ping. That's you guys. We got you. You pinged us. What? You guys are detecting pings? Seriously? Oh yeah, we do it all the time. Yeah. Oh yeah, we detect all pings. We were doing one. I was just doing one a couple weeks ago for an insurance company, and the head of security he puts us in this like tiny security guard shack because he didn't want anybody to know that we were there. And so we're in there hacking away, and we get access into like everything, and we're like breaking into stuff left and right. And we're like blasting stuff everywhere. Like we're hitting things with hammers, and no detection at all, right? And no one's saying anything. And this guy comes back, and he's like, "Hey, you guys do anything?" I'm like, "Dude, we own everything, like everything." And he's like, "Okay, well, you guys can move into the normal building now. Let's see what happens." And literally, as soon as we moved into the building and sat down at this table, and we made one little packet, I think we just got a DHCP address. The security team homed in on us and was like, "Hey, what are you guys doing out here? What are you guys doing? We detected you plugging in here. We got this. I'm like, seriously? But real world scenario. So, we go in from a red team perspective and, we attack you guys and maybe you pick up some of the stuff, but, we're using, IP addresses from all over the place. So you just look at it as legitimate or, traffic, you block that IP address or whatever. And then we find one flaw, just one little flaw in your entire infrastructure, and everything goes boom, right? Whether that's social engineering and phishing somebody, one person to click an email, right? And it's funny because I love using the example of phishing attacks, because what we typically see is the company was like, "Hey, I want you to send 5,000 emails out at the same time to see if we can detect you." And I'm like, all right, listen, let me just ask what your purpose is. Is your purpose to see, just how many people click a link and you're not going to say anything or detect your, if it's not, and you actually want to do a real world scenario, you only send it to 2 people and you wait. You just sit there and you wait and you don't do anything. And then you maybe send it to another 1 person or 2 people. And then you wait a little bit to see what happens. And let's see how your detection capabilities are, because that's real world. And funny enough, I was doing a pen test recently, and actually it's been 10 pen tests. Anybody ever heard of Phone Factor? All right. So Phone Factor is interesting because, it'll send you a text message or it'll call you, right? And it'll say, "Hey, are you trying to log in right now? Yes or no?" And it actually gives you a link for the yes or no. The last 4 pen tests that I've been on, all right, I grab I harvested the credentials and I go into log into VPN or OWA or whatever, and we get into there and it prompts and it says, "Hey, we're calling you right now to see if this is you logging in." And the first time this happens, I'm like, uh-oh. And all of a sudden I magically logged in. And I'm like, what? Is something broke? I'm like, you guys, so I thought it was a technical finding. Automatically, I'm like, hey, folks, I just want to let you know that, I think your 2 factors broke because, it automatically logged me in. And they're like, "Oh my gosh, we have to investigate." So they enacted incident response and all this other stuff. And they interviewed the user, and the user's like, "Well, I'm always logging in somewhere. My mobile phone's always connecting and stuff. I figured it was just something like that." The funny part is, that's happened on my past 4 pen tests. So every time I see Phone Factor, I'm like, yes! I know I'm good. So what I'll do is I send an email and I'll log in and say I'm calling it. I'll go grab a beer, and by the time I get my beer back and sit down, that person's already logged me in. So it's perfect. It's great. 2-factor fail. So the blue team side.
So, one thing I wanted to hit on what Dave said about, as a blue team guy is, we see pen testing coming, or we hear that there's going to be a pen test coming. The first thing we want to do is we got to make sure we detect this. We don't want our boss coming in and going, "They've been here for 2 weeks. What's going on?" No one wants that, But what good does it do us to know that pen test is coming? How many here have actually gone through a pen test and not had any kind of hints or anything before it happened? It's good. So, I used to be at fault. We used to hear that Dave was coming in, and the first thing that me and my counterpart would do would huddle up and try to figure out how we can know when he's coming in. So, I'm going to say it. So, what we did on the last time that they came in was we went to our boss's calendar. Now, what does he do? He shared the whole calendar with his team. So he had a meeting appointment that said meeting with the company. I said, okay.
You son of a...
Oh, but it gets better. Not only did it say meeting with this company, in the body of the message was to discuss the pen test that is on these dates. So we get all excited.
I was wondering how you guys got me, because I'm like,
So, we may have been one of those examples that was like, oh, we saw a ping. Because, we knew exactly what was coming. And we didn't tell our boss until the entire engagement was up. So they plug in. We knew about what time it was. Our boss decided, he had an off-site meeting. So we're just sitting there waiting and waiting. And as soon as we see it, call him up. Hey, you need to tell him. We caught him. We got him. And he was all excited. He's like, wow, we did great. But, really, what did that do for us? What did that do for our program? What if we wouldn't have seen him? That doesn't do us any good. We want to really be tested, and you should want to be tested. You should want to make sure that your defenses are working.
And so on the blue team, does anybody here not have a million projects that they're dealing with on a regular basis? You guys work on the blue team side, raise your hands, blue team. Who here works over 40 hours on the blue team? Not one hand dropped. Not one hand dropped. Red teamers, raise your hand. Who here works more than 40 hours? 5 dropped, a couple, there's 2. That sucks. Seriously, it does. I don't know. I'm a red teamer, right? I do blue team stuff too, but I work like a million hours because I write set modules every day. But listen, you're dealing with all this stuff. Let me ask a question here. Blue teamers, raise your hand one more time here. How many times when a critical patch comes out, who here has more than 5 meetings to discuss that emergency patch? Yeah? Lots. It's a tiring process because we have to deal with irate people, especially when we break something. Anybody broke something doing something security-wise? All the time, right? We're like, oh no! And then your heart's racing. You're like, oh my. So I was when I became the CISO at Diebold, I like to know my network and understand what I'm attacking, right? And so there was this web application that was the core for all of our managed services in our company. So I'm going in and I'm hacking away at it, and I find a SQL injection flaw. And I'm like, boom, 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 hitting stuff and drop. Not dropping tables. Sorry, I'm selecting tables, and and I accidentally did a true statement on a forgot password, which. The way that it was coded, it did a loop through all of our customer databases and overrode them to the same password. And this is I'm talking a big deal, right? So I'm hacking away. I don't even know I did it. I'm just got shells. I'm ripping apart. I'm yeah, I'm gonna do this. All of a sudden I get a call, and I get a call hey, and this is, by the way, this is my second week working at this company. Hey, are you doing something to this application? I'm like, maybe. I'm like, what's going on? He's like, all of our customers are locked out and blah, 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 and the whole thing's down, and people are screaming in the background, and I'm like, maybe. I'm like, hey, I gotta go. Click and just run out, but, and it's funny too, they'd have meetings at Diebold, and they'd have the top offenders, from McAfee or their intrusion prevention systems and everything, and this was the IT meeting to discuss who the top offenders are, the top hackers, on geographic location. And for 6 months running, I was the top threat to the organization.
It was actually a little bit longer than that, but we just stopped putting them up there.
Well, that's what another one I didn't. No, but the truth of the matter is, I mean, we had a great team that focused on a lot of that stuff, but it took a long time to build it. But in today's environment, it's not possible for the blue team to be successful or even stop attacks because of all the things you have to deal with. The red team, in some way or another, is always going to win, no matter if it's a certain amount of time. I mean, if we have 2 days on a pen test, maybe we don't, maybe we do. But in the most case, we're always going to win and find that one bug and then rip everything open, and the blue team is going to be stuck with cleaning up all the damage of our aftermath. And it sucks. It's not the right way we're looking at it. So let's talk about the purple team. I think I first saw the concept of the purple team from Mick Douglas, is where I first saw it with it, which is, you know, a combination of the blue and red working together. And here's where one time I was wrong on something. When I was writing P-tests, I was preaching P-tests and the penetration testing execution standard and everything. I recommended that we should always be doing covert pen tests. We should always be going after things from a blind perspective. I was wrong. And the reason for that is, do you learn anything when we come in and we blow you up, or you're playing the cat and mouse game with calendars?
You gotta do what you gotta do.
Do you learn anything from those scenarios? Are we really even detecting anything right now anyway? I mean, really? I mean, if you have an MSSP, what, you're detecting port scans? Maybe semantic tripping on a virus, right? Or someone getting added to the domain admins group, and you're like, oh my god, he's added to the domain admins group, we gotta do all this, right? We know those techniques, and we go around it, but why? Why do we have such a disparate group where, you know, I'm always the one that's the rock star coming in and blowing stuff up, and the blue team is always the ones fixing it, and you guys are working the most hours. You guys are the rock stars. We're just smashing things with hammers. That's an easy thing to do. The fixing part is where we need to get more into and understand what we're doing and looking at that.
So like Dave was saying, we've said it a couple of times, the two teams need to work together. We need to understand attacks. You know, the guys on the blue team, you know, the guys who work, we need to know more about what the hammers do. We need to understand how that works. You know, even if we took that step and we said, okay, here's the report, here's the finding from the pen test. Okay, this is what we should start monitoring for. This is what we should do to fix it, or, you know, whatever it is. That's good. That's a great start. But we need to understand how they actually did that in order to know what we're doing, you know, to defend better.
And as an example of that, after a pen test we'd get done at Debo, for example, we had a great team. Carl's over here and Dave over here as well. All, you know, former folks from the team. What we would do after a pen test is we'd sit there for 3 weeks afterwards, and it's the only thing they're allowed to work on for 3 weeks to triage that pen test. What did they do? Let's go back on all of our artifacts and look at exactly what they're doing so we can build our detection capabilities around that exact thing, and where we have gaps at, how can we improve? And we got to the point where we're running 2 consecutive pen tests or 3 consecutive pen tests at the exact same time from different companies. And it was funny because, I was in charge of the incident response piece of handling communications and directing and all that good stuff, right? So what I would do is I would hire these companies, and one of them was Lara's, Nickerson's group. And Nickerson's coming in and basically, creating a pretext and doing social engineering and spear phishing, while we have another company that's inside breaking away and everything. And literally, I went on a flight to China right as it started. And it happened to be the same week that they're going through network migrations, which is the worst week I could have ever did, and I did it intentionally. So it was chaos all around because I couldn't be called. We had 2 people coming in at the exact same time, and we're going through network migrations. Now, when I got back, my voicemails were full. I had like 6,000 emails, but they handled it, and they figured out how to do it. And we spent the next 3 weeks figuring out why we can do it better. And we worked on that, understanding the offense. It's important. My team hated me sometimes, by the way.
I was just going to say that, so thanks. No, that's what I was going to say.
All right. So this is what your pen test needs to look like initially, all right? For the first few years, do not do a blind pen test, period, ever. Just don't worry about it, all right? And if you got to do it for some regulatory requirements, we'll slam a scanner at you really quick, and you can just say you detected it, and then we'll move on to making it look better, all right? You need to understand and sit with the blue team. The blue team needs to sit with the red team and figure out how we're going back and forth and doing what we're doing. Things that we can look for, things that we can focus on. And the blue team needs to sit there and understand exactly what we're doing because you know your infrastructure better than any of us. You know it better than anybody else inside of that company because that's what you do. And so if you understand how we break in, you understand how we can defend your infrastructure, your data, your company's data. And the purpose is, if you look at life cycle of an attack, okay? You look at everything from, the intelligence gathering phase, threat intelligence, vulnerability analysis, exploitation, post-exploitation. Those are all things that you should be able to detect on throughout that whole life cycle. It isn't like detecting, hey, we can detect MS-067 over the wire. It's like, hey, we see abnormalities based on all the stuff that we've done in the past. Now we can start looking for that. So here's an example, right? A really easy example. Does anybody here, if someone port scans your external perimeter, or even on your inside, do you block them automatically? One hand, two hands. Does anybody know what you do to a pen tester or a hacker when you block a port scan? It pisses him off, and it gets really annoying. It gets to the points where I'm like, listen, I'm routing all my stuff through Tor, and it's so friggin' slow. Can you please just whitelist us? So if you do simple things, like detecting web scanners or vulnerability scanners or port scanners now, so you literally eliminate like 50% of the noise out there. Now you're only starting to focus on other things. So if you remove the noise, you remove the easy stuff. Let me ask you a question. If someone port scans you right now, do you trigger incident response based on a port scan? No, right? Why would you? You're getting a million port scans every day. Someone runs a vuln scanner on your outside. Are you enacting incident response? Maybe, maybe not. Do you need to? Possibly. But is that just noise? What happens if I eliminate vuln scans, web scanners, and port scans? What does that do right there? Those three things. That removes 90% of what you're dealing with right now in noise. Now, what does that do for you? That you're already understaffed and under budget and everything else. What does that do for you? Now you're looking at 10%. Now that I have 10% here, is that more manageable? Can I focus now on getting to 5% and 4%, maybe even 3%? And we keep making it better and better and better over time to where we're only looking at the right stuff. And that's the difference.
So along with that, you need to properly tune your SIM so you can get information and get alerts about what's important. How many people here on the blue side have metrics that they have to report on? Right. So out of those people, how many of those metrics are like number of alerts in time X? Okay. And that's supposed to be something important, right? Oh, you know what? We had 2,500 alerts this month. Okay, that means we're detecting all the things, right? Well, what if you take out the stuff that doesn't really matter? Tune your SIM. I'm not saying ignore it, but just tune it properly. Do you need to get an alert? Do you need your phone going off every time there's an external vuln scan? Well, probably not. But if you tune your SIM to, let's say, you have a vuln scan, and then you have, a different type of attack vector coming in. Well, from the same IP, for example. Well, that's more important, right? Isn't that something that you should focus on and spend your time on alerts on? Because, and I've heard a lot of red teamers say, well, for example, if you monitor the SIM, all you're doing is sitting there.
Why'd you look at me when you said that?
What do you think?
Okay.
But you're a monitor watcher. It's not true. All you're doing is watching a monitor and watching things go up and down. Looking at different dashboards, making it look pretty. But what if, how many people here have never missed anything that went across the SIM? Right. Why? Because we have all this noise, all this traffic going through. So tune it. Tune it the right way. So I was going to do a demo, but we're a little bit short on time. I'll walk you through the two demos, though. Okay. One is the social engineer toolkit, the Java app attack. Has anybody ever not seen the Java app attack before? Okay, good. So I'm not going to demonstrate that. Good. The new version is set. It incorporates Matthew Graber's attack and all that good stuff. But I've done a little bit more on more of the polymorphic engines on it. So it's a lot more. Every single time it generates a whole new set of code that's not the same every single time, and then it puts AES 256 on top of it with the dynamic cipher key, and then does a bunch of other stuff. Anyways, so those techniques don't really get picked up, which is nice, and everybody uses Java. It's always beautiful. We love Java dearly. The second one, hang on, I'll get to that. So Java's the one, and by the way, Java by far is our #1 most method for attack. I mean, if you're blocking Java, that hinders a lot of different attacks. I'm also going to be releasing a new attack vector that doesn't exploit Java. It uses like basically browser bugs, but then that's going to be even worse probably than Java. But until now, Java's the worst. Okay. And the Java side is pretty difficult because everybody uses it for the environments.
Now, the second one I was going to use is called webjacking, which we teach our users to, when an email comes in and there's a link there, what do we tell our users to do? Well, everybody's got to click something, unfortunately. If we could eliminate that, that would be amazing. But the hover, right? And so the hover is one where you hover over the link and make sure it's legitimate and everything, right? So the webjacking attack takes advantage of that and uses an iframe replacement attack where when you hover over the link, it looks like a legitimate link, and you click on it, and it takes you to the legitimate website, but it's a time-based attack where it redirects you back to the malicious site without the user knowing it, and then enter their information in. So you defeat the hovering technique, which is everything that we tell our users to do. So those are the two attacks. Now, we're going to play a quick game real quick, all right? I want you to pick A through D, all right? Which one you would do. So, which one's the best solution for each attack. So the first attack here, for the Java one. Which one? All the above, right? All right, for reals. Which one's best here? All of the above, you're right. So in this case, what you could do to disable a lot of these attacks, most pieces of malware or what they execute from, either execute from temp or from all users' profiles. So if you disallow execution from that, and by the way, you can do that by default in App Locker and group policy. You can say disallow execution from temp and all user profiles in group policy and push it down, and you're literally going to eliminate like 80% of your malware. Because that's what all downloads do. So disallow that, and you actually stop a lot of the stuff in set as well. Next is PowerShell is really difficult because it's so powerful. We love using it, but it's needed and it's integrated into the operating system. What you can actually do in App Locker is you can disallow PowerShell execution for regular users, but not administrators, across the board through App Locker, and now you've stopped predominantly all the PowerShell injection attacks in set or what we continue to see in the wild. So really simple to do. Now in that case, you need to make sure that you're protecting, there's two folders that you need to protect. One is under the system32/PowerShell directory. There's also another one in c:\windows/syswall64, and there's a PowerShell directory underneath there too. You need to block both of those, because if you don't, sorry, it works. Because there's two locations. One is the PowerShell, which is going to be your 64-bit one, and then you have the syswall64, which is going to be your 32-bit compatibility one. So if you don't block those two areas, you're vulnerable. Okay? And then obviously remove Java or secure it if possible. I've seen a lot of folks put Java in more of like a Citrix environment or like a app V type environment where they double click it and it's in the app V area and then the VMs get deconstructed afterwards. That also helps a lot too. And nothing's bulletproof. I got around App Locker. I figured out a way around App Locker. And I also demonstrated how to get around execution restriction policies. And that's a quick proof of concept to do that. But again, it's defense in depth. Also, there's the magic unicorn attack, which is what is in set that actually compromises the machine as well. Now, the webjacking one's tough because you're targeting education awareness and human weakness. Let's talk a little about that. Which one's best fit? A, B, and C. And the reason for that is education awareness is important. Looking for, obviously, malicious links and things like that. So I mean about the uncategorized feature within web content filters. Those are amazing, right? Check, block uncategorized sites, and you're going to eliminate about 90% of the quick hacks or phishing sites that you see out there. And those really help in your website filtering. And B, possibly two-factor authentication in some cases, implementing it properly. Don't allow the user to click a link to do it. They actually have to enter a code in or something like that. So some things to ponder real quick. The uncategorized sites are good. Enhanced Mitigation Experience Toolkit, if you haven't seen it, definitely check it out. Emmet's one of my favorite ones here. It's a free download from Microsoft, and it looks at a lot of different ways that we exploit things. Like, for example, one of the techniques that I typically use in exploit dev is called return-oriented programming, or ROP. It looks for a lot of those different types of bypass methods inside memory, and it's free. You can deploy it across. I have it deployed across our entire infrastructure. I've seen customers deploy it corporately for large portions. Done a lot of implementation around that too. There's ways around Emmet, but it's pretty difficult to do. And this is actually an interesting one. This was a IE 0-day. Spider Labs did some research on it and analyzed it. And it was checking for the Emmet DLL. And if it found the Emmet DLL, it just killed itself and didn't run the exploit. Pretty cool. So how do you detect attacks? Predominantly B, C, and E. Now, if your next-gen firewalls are feeding your monitoring detection program, sure. Antivirus is just, I mean, we've hit that with a hammer and destroyed it with a bazooka and everything else out there. There's nothing you can do with antivirus. It's a dead technology. It's done. So talking about bringing sexy back, I'm a big JT fan. Him and I kind of go way back. For me, the blue team has always been considered not the sexy ones, right? To me, the blue team is very sexy. And you are the defenders of your network. You're the guys that deal with all the politics and all the implementation strategies and going through ITIL and having to go through your change advisory board, then your change control board, then that board for that other board, then a meeting for that board, talk about that board for that board that you need to go to tomorrow. You guys are the defenders, and you're dealing with all this stuff, right? That's sexy. Oh, don't get me wrong, the meetings aren't sexy. Those suck. And you guys are just doing email anyway, like, yeah, what's up? Anyways, we have to be a combination of both to kind of bring that sexy back. And the reason for that is if the red team is considered the sexy ones in the industry, and we're combining the two, why can't the purple team be sexy too? And that's what we hope to get out of this, and from you talking, working on more long-term defensive strategies, because we change our techniques every day. We go on a new pen test, and we're like, hey, we figure out a new way to break into something or do something different that we haven't done before. You, on the other hand, have to figure out what that is so that you can detect against it, or if you see an attack in your infrastructure that's coming from black hats, or folks in the wild, you need to understand how to detect that and keep going forward. If you look at education awareness, it's been interesting. Education awareness in InfoSec has always focused on the end users. Where's the education awareness for the InfoSec folks? We don't have that, do we? Well, yeah, you guys are here. That's cool. Yeah, that's true. You guys are learning now. Okay, that's good. Thanks for coming to DerbyCon, by the way. So what I recommend, and we'll wrap up here, of different levels of readiness. This is what I like to call, level 1 through level 5 of how you kind of mature forward. Level 1 is looking at just simple stuff, port scans, NIC2s, WIC2s, W3Fs, or whatever, and understanding that. Does anybody here understand all of their ports and protocols, what versions they are on their outside perimeter? Sorry, guys, that's your first step for level 1. You need to understand that. You need to understand what ports and protocols you have on the outside and what versions they are and everything else you can from mapping an application. That's your most important. That's going to be your highest level of attack out there. Got to do that first off. Level 2, start profiling your web applications, looking for normal traffic, looking for abnormalities in that. Focus on egress filtering. Egress filtering is a way that I connect out to the real world as an attacker, and predominantly how I get access and connect in. Also developing a threat intelligence program looking at different types of attacks. Level 3, make it difficult for pivoting and post-exploitation. Does anybody know when I break into a machine, or a red teamer breaks into a machine? We break in, we extract the hash values off of there, and then we use the pass the hash, or we crack the passwords, and then we leapfrog to other systems, right? Just disabling the local admin account, you can do that through group policy, by the way. I did a blog. You can do trusted sec disable local admin. Or you maybe have unique passwords per each box, great. But doing that makes it a lot harder for me from a post-exploitation perspective. Removing domain admins from ever being able to log into member servers limits and protects your domain. I have to find a bug now in your domain controllers. Not having domain admins and logging into member servers is great, right? Different segmentation of roles and responsibilities. Level 4, now you start to get into testing the effectiveness of everything. You know how many times I've been in a pen test before? We break in, we add a domain admin, we're sitting there waiting for the whole red team to swarm in on us and tackle us, the blue team, and they just don't come. And you're like, what's going on? I know they have rules in there or whatever. And so we're waiting. We'll walk up to like, hey, we just added a domain name. I'm like, how long ago? I'm like, I don't know, like 3 days ago. They're like, we never got an alert. Oops. So then they go check and like, oh, we had it misconfigured. Now it's working fine. That's always what we run into on the SIM side. Not detecting things. You need to test those and make sure everything's working appropriately. And level 5, here's when you start getting into, zero-day stuff and, looking at patterns and things like that. Working on high security zones, isolating segments, all that stuff is level 5. And level 6, last but not least, this is when you can start doing covert testing. Level 6 is when you've graduated college and you can now do covert testing to actually look at things and actually understand the types of attacks and triaging. So wrapping things up, we are getting better. This isn't a thing that we're doing horrible and this, the whole world's ending and we suck awfully. It's not the case at all. We're doing great. And security's all over the place, and people are getting more and more excited. Has anybody here over the past 3 years got more interest from their company in security? Look at that. Almost everybody in this room. It's wonderful. We're getting there. We're just getting the right message out and keep it moving forward. Heartbleed, for example, use that stuff. Like, promote the living heck out of Heartbleed. Like, oh my God, the world's ending with Heartbleed. We need to get this and this and this and this and 10 people and we'll be good. Use that stuff to your benefit, all right? Shell shock comes out like, oh my gosh, our entire company, I understand we're IAS, but our whole company's vulnerable to shell shock. We gotta get 5 more people in here to fix shell shock. Use that stuff, man. They have no idea. You could be like, psst. This says it only impacts Linux and OS X, and we only have Windows 100%. No, trust me. They're just converting the exploit over now. It's Bash. I know Bash is on Windows too, so we're good. You start talking like a whole bunch of stuff like, well, syscall 64 can be converted to 32-bit DLL binaries into Windows, and then it could compromise us. You'll be like, all right, I'll get you 5 people. It's cool. You know, it's... Use that stuff in the news, man, because they're seeing it all over the news, and they're freaking out, and they're like, oh my gosh, am I vulnerable? Yeah, we're hella vulnerable. Even though it's an apt-get update and apt-get upgrade, we're vulnerable, right? We need 5 people. Yeah, we're done. Are we out of time? Yeah. So last but not least, I had to flash through some slides. Last but not least, I mean, build a purple team, employ good hackers, integrate them into everything you do, and start to really build those defensive capabilities. And closing things here, until we train and train hard, we have to prepare ourselves on the offensive capabilities. We cannot have an effective defense without an offense or good defensive countermeasures. Thank you.
Thanks.